Hi, everybody. So today we are in engineering surveying and practical surveying, and this is our first lecture of the year. We're going to take about a half hour to talk about classroom procedures and how to make sure you succeed. So this course is very valuable for engineering students. And some fields of engineering, it's an elective, some fields it's a requirement. So if you're in civil engineering, mining engineering, geological engineering, architectural engineering, this is a dead-on requirement. If you are in a different field of engineering, it is an engineering elective. Practical surveying is a course I wrote 10 years ago, maybe, to serve the needs of our drafting students. So it's not an easier course. The lab portion is identical, but it's designed for a student who wants to be a drafter or an engineering technologist or technician who would go to work maybe for civil or construction firm and needs to know how to survey. So the labs are the same. And the other thing is it's always really good to have engineers work with drafters, because quite frankly, we get to work with each other for the rest of our lives. So we might as well start in here. So it's a good combination. All right. So in order to be successful, what I'd like to do is to take a look at our Moodle page. And like I said, the Moodle page that you'll be looking for under your online classes is called Engineering Surveying, even if you're in Practical Surveying, but it has the numbers of the courses, ES 2070 1H, which is Engineering Surveying, and ES 2671H, which is Practical Surveying on here. Hang on. There, all right, that's better. So our Moodle page is contained in that everything that you need to be successful is here. The first piece of information, if you look, I've organized this by topics. We have some introductory material for our first class meeting. That's what I'm going to record. And then we have a lab for today, which we will do. We'll talk about how that's going to work and we'll execute the lab, but that part will not be recorded. That's just what we're going to be doing today. Then there's some more material that we'll talk about that will be available here. But the way to succeed in this class is when you look at the date, just make sure that you have just read through the material, items that it says to do, and be prepared for what happens on that day. Okay, so since we only meet once a week, and our real meeting face-to-face is the lab portion, it would be unusual for me to lecture. All of the lecture material is pre-recorded and it's on our Moodle page. So that means that it sort of shifts the responsibility of getting the material from the teacher to the student. So this is really what's called a flipped classroom, which means that you, instead of being together for lecture and then going home and doing your work, you do the lectures on your own time, and then you come together when you need help with me to get your work done. And then of course we do the labs face-to-face every single time. Okay, you'll also notice that there are two syllabi. One is for practical surveying and one is for engineering surveying. So I'm going to take a look at each one of those. Before I get started with that, I just want to point out, if you see, when you read the titles, for example, we're talking about the lab, that's going to be for everybody. Sometimes there will be a lecture that says practical surveying. If you're in engineering surveying, you do not have to watch that lecture, okay? And then engineering surveying, chapter 1 lecture for the introductory. So the engineering surveying students will want to watch this lecture. Practical surveying students will want to watch this lecture. If you watch both, you will not die. You will just get some of the same material from a little bit different point of view. Okay, same thing goes for assignments. You'll see that assignment number 1 is different for engineering surveying than it is for practical surveying, but you'll turn them in the same place. So it all goes into the same place. And then I just sort it out on the other end. Okay, so having said that, let's take a look. Hang on a second. And take a look at the engineering surveying, since there are more of you guys. We'll take a look at we'll take a look at the syllabus for that class. And we'll continue with this. Okay, so engineering surveying has a math prerequisite of math 1405 or math 1450, which means you have to have trigonometry in order to approach this class. And it's a pretty functional type of a prerequisite. In other words, you need to be able to do some trig in order to be successful in engineering surveying. Practical surveying has a different prerequisite, which we'll talk about in just a moment. But what we do, has anyone ever heard the expression good neighbors make, or good fences make good neighbors? Yeah, so that's what surveying is all about. I mean, there's two aspects to surveying. There's an aspect called land surveying, which is about defining boundaries, who gets what, right? Put your fence here, your neighbor has this side, you have this side, and it makes everything work really well if you're not fighting over a strip of land. The other type of surveying that we do, both engineers and drafters, is construction surveying. Buildings have to have a certain size, the floors have to be flat, the walls have to be straight and true. And they also have to be on the land that you actually own, because putting a building on a land you don't own is a terrible idea. So these are the kind of things that engineers are concerned with, and that's what we're going to learn how to do. We're going to learn the ideas behind both construction surveying and land surveying, and then we're going to use some of the equipment to do surveys that will get you ready to do those in your careers. Okay, so some of our objectives, like it says, gain factual knowledge and terminology of surveying, to learn basic surveying methods and calculations, to use surveying equipment and conduct engineering surveying, to use proper equipment handling procedures, to interpret surveying data, to understand error propagation, and to adjust random and systematic errors, which we'll get into over the course of the semester. So for engineering surveying, the textbook is called Elementary Surveying, and you will need to purchase this book. This textbook that I have is the 14th edition. You can get a different edition if you like, but it has to be written by, the author's name is Gilani and Wolf, and this is on our college bookstore online. So it has to be that author, and it has to be a 10th edition or more of this textbook. And whichever one you do, we can work with to make sure that you get all the skills and do the homework problems that will be appropriate to get you ready for the midterm exam and the final, and to ultimately have the information you need to go forward in this class. So the other thing that you need for this class is called a field book, and I have these for you. These are very, very important. Let me put this, they're so important. I would like to stop sharing for a moment. This is an engineering field book or a surveying field book. And there's some features about this book that we'll learn today and as we move forward. But one of the things that you'll notice about the one that you're going to get, I'll just pass these out right now. They have a bound edge. So an appropriate field book does not ever have spiral bound, and you can't pull a page out of it. Pulling a page out of it is actually a big no-no. The reason for that is these actually are legal documents. And so like if you're ever called to talk about your work in a court of law, this actually supersedes electronic data. So it's important that you record stuff in a meaningful fashion, which you're going to learn how to do here. So I brought a couple of, these are like little field books. This looks like a field book, but it's not actually a field book because it has a ring binder. The one thing that you can never do, like I said, with a field book is tear a page out. If you ever tear a page out, that means that you have done something incorrectly. So we will talk about, I mean, one choice we would have is to write everything down perfectly the first time, which is not a logical solution. So we'll talk about how you address an error when you write something down incorrectly. But we have to do that according to what's required of a legal document. This is a good field book. This is actually one that I have used I've used for years. I have stacks of these. And if you ever go to an engineering firm, they will generally have a closet full of these that are labeled, you know, by number, by name, by what the job was, whatever. But these things are held on to forever and ever and ever, really. I mean, the field notes just go on. They never die. There's a place in Cheyenne here in Wyoming, for example, called the Bureau of Cadastral Surveying. And every survey that's ever been done in the state of Wyoming is recorded there in field notebooks. So, yeah, pretty cool, huh? I think I hope I have an opportunity to show you some examples of that as we go through the class. All right, so getting back to the syllabus. The one thing I wanted to do, which I didn't make a point of, for those of you who don't know me, my name is Astrid Northrup, and my office is right across the hall. Right across the hall is office SM 115, mine is 117, so it's inside. And anytime I'm in there, you're welcome to come by and visit with me if you have problems, you have a question, anything at all. The other thing is I do not keep posted office hours because I'm here all the time, in addition to teaching on division chair, which just means I'm here all the time. So what you do if you need to get a hold of me is you can come by, and if I'm not there, go to this link on your syllabus, Calendly, and you can set an appointment with me. So Calendly will automatically create a Zoom link, but you can come by my office. You can do whichever one you want. Either we can Zoom or come by my office, but that's how you get a hold of me. And I'm always, during the semester, I'm almost always available. You can also email me or you can call me. I will sometime today or tomorrow forward my office phone to my cell phone, because then I'll for sure get your messages. But I did change my voicemail to say, please don't leave me a voicemail. It texts me. So either text me or email me, because I don't check my email. I don't check my voicemail. Check my email consistently, check my text, but I never check my voicemail. So if you leave me a voicemail and I don't answer you, it's because I don't know that you did, because I don't look at it. So just send me a text or an email is better. All right. So we've got the field notebook. We've talked about the text. And then there is this blurb that says, since we will be outside in all manner of weather, students must have appropriate outdoor clothing. May include, not today, obviously, coveralls, hats, coats, gloves, boots. Do not come to lab without outdoor clothing. We don't use weather as an excuse to stay inside, and expect to be outside for all lab periods and dress appropriately. So if you think about yourself as a working professional, a couple years from now, why do you think we don't use weather as an excuse in this class?
Everybody's out there.
That's it. If you're working for a living, you're gonna be out in the weather no matter what. So it's also probably really true that I don't think most people do their best work in screaming blizzards, you know? So I mean, there may be a limitation, but we just go out, you know? Then I'm trying to think, I've taught this class for many years. I can't really think of any time that I've ever canceled the lab because of weather. So just make sure you wear appropriate clothing. Today is beautiful, you know, I mean, we're all fine. But the other thing is, like I said, please don't wear open-toed shoes, even if it's a beautiful day. It's just not professional. It's not the expectation of the industry. The expectation is that you're wearing footwear that's appropriate to carrying equipment and being outside. Okay, so in engineering surveying, there are 4 components to your grade, and each one of them is equally weighted. There's lecture homework, which will be on the Moodle page. There are lab exercises, which we do today, and I'll give you a grade immediately. Then there's a midterm exam, which is 8 weeks in, and then a final exam. And each one of those things is worth 25% of your grade. There's really no way to get around attending lab. I mean, I understand sometimes something crazy happens, but in general, be here. And then at the end of this first 8 weeks, I'll have a makeup lab for people who've missed the lab. And at the end, I'll do the same thing. But what the real goal is just to be here every single time. Okay. And if you can't be here every single time, be here almost every single time. Right. So having said that, let's take a look at the practical surveying syllabus, and you'll see it's much the same, except for the percentages of grades are a little bit different, and the book, of course, is different. The other thing that's different about it Practical surveying is a 2-credit course. Engineering surveying is a 3-credit course. So since we have the same lab, probably makes sense that there's more homework in engineering surveying than there is in practical surveying, because there's just more content that we have to deal with. Okay, same thing, we've got the lecture, we know where we are, you know where my office is. Set up a meeting with me if you need to visit with me, or send me an email, or send me a text. Okay, so this course does not transfer if you're going for a 4-year degree. So, for example, one of your classmates who is not here today took practical surveying a couple of years ago, and now she's decided to be in the engineering program instead of the drafting program. So she's going to do the lecture portion of this class, and she and I are just going to discuss the lab portion. So she may come to a lab or two, but she's not required to, because I already have her records from a couple of years ago. Okay, but if you need this course to transfer, the course that you need is engineering survey, and it transfers beautifully. It's kind of a surprising number of courses that a person can take in surveying. You can actually get a 4-year degree in land surveying. One outlet for surveying is lawyers. Sometimes lawyers will become licensed land surveyors, or licensed land surveyor will become an attorney. And there's just a ton of work for people like that. So, there's a lot that can be done. It doesn't really have to do with measurement. The measurement stuff takes place in the first few, maybe 8 or 9 credits of surveying. And then beyond that, it's legal work and regulatory work. So, but there's a lot you can do with surveying if you're interested. So once again, what are we looking at? We want to learn how to measure distance, elevation, angles, using surveying equipment. We want to learn proper equipment handling procedures. We want to learn methods of recording field data and other skills required to perform surveying duties. Okay, the percentages here are a little bit different. You notice that the participation in lab exercises is worth a lot more than it is in engineering surveying. They're both, you really can't pass without doing the labs, no matter which class it is. But because practical surveying is a 2-credit course, and the lab is 1 credit, obviously it's worth more than 25%. Okay, field books, you also get a grade for that. And I will teach you very clearly how to write out your field books, okay? You do not have to buy a textbook, but I will find you a copy of the textbook, which, like I said, was a big shock to me that I'm out of them, but I've just given them away over the years, and there they are. But I believe I have 3 or 4 copies in the library, so I'll make sure that we're squared away with that as well. This and the other one also said all of your homework has to be scanned and handed in through Moodle. I don't accept paper homework at all. So I'll talk about that a little bit on our Moodle page, but I can't, everything has to be scanned as a PDF or as a backup, maybe a JPEG. But if you have an iPhone, it puts things in a format called HEIC, an extension HEIC. I can't read those, so please don't send me anything like that. So get a JPEG or preferably a PDF. Those are my 2 favorites. Okay. All right. And the homework that you do, you'll be doing on your own with my help, or you can work with your classmates, which is approved, beyond approved. Or if you have questions, you can come find me. The midterm exam and the final exam are both proctored and a solo endeavor. You'll get a sheet of paper. I let you do a formula sheet so you can write things down that are important to you, that you feel like would be helpful to you on the exam, but obviously they are proctored, sitting in this room doing the exam. Okay. All right. So at this point, does anyone have any questions or comments? Yes.
So this is the last time, right, every week?
Yes, that is correct. We moved it up. We had started it at 2 o'clock in the afternoon. I moved it up just because of some conflicts. So I've never done it this early in the day. I've always done it way late in the afternoon. So hopefully it will work out for everybody. So, but yeah, every Tuesday from 1 until 2:40 we'll meet. And most times we'll just start, I'll just take some questions if you have anything that's been, that you'd like to visit about from the week before. in the homework or any of the assignments, we'll do that, but I won't do a formal lecture like this. All lectures are already up on on Moodle page, so, all right. So, having said that, let's go back to our page. Okay. How do you know when you need to turn something in? Well, because it will tell you right here, okay? So basically, like I said, when we were talking about, when you see the day, January 13th, which is today, or if you saw a date in this week, you know, you would look at all of the stuff here. You would look at the syllabi, you do the introductory lecture, you would read the introductory lecture. These will be replaced by what I'm doing right now. So if you've been here and you don't feel like you have any questions, you don't have to rewatch that, okay? But then you will come up here to lab number 1, and this is what we're going to work on today. But there is some additional material here for January 13th. So we have some note forms, which we'll talk about. We have textbook appendices, which tells you how to write note forms and some other things. And then there may or may not be an introductory lecture. But here we do have an introductory lecture for practical surveying. And we also have a lecture for engineering surveying. So if you're in engineering surveying, you watch this. If you're in practical surveying, you'll watch this, okay? Then when you have a lab, and that'll always be labeled like that, lab, okay? The grade for that will be based on your work today. And it's not a sliding scale. If you're here and you participate, you will probably get a 10 out of 10, okay? Or you get 100%. The homework is a little bit more subtly graded, you know, but so I do this grade, you don't have to turn anything in for your lab. But when it comes to your assignment, so engineering surveying, for example, you'll do that and then do these problems. Practical surveying, you'll read this and do these problems, and then you will submit it right here. Okay, and you'll also see it has a due date, 27th. So we have 2 weeks to get the first homework in. And it's not because it's a difficult homework. Most homeworks will be just 1 week, but sometimes it just takes a while to get used to the organization and how you turn things in, and it's just better to start off and make sure we all have those things ready to go. Okay, I have some hidden stuff here, which is, you're not gonna even see that. That won't even be on your page, but I keep some stuff there. All right, so there are a couple of things. That's for pegging in. I don't want to show you that. Okay, so when we talk about an example note form, we're gonna talk a little bit about field notes in just a moment. But everything, when I talk about field notes, I'm always talking about what you're gonna write down in this book, okay? And it's not that you write a humongous amount of stuff in this book. However, what you write here is very important. So we need it to be in a proper format. And I'm gonna teach that to you. So it's also in your book, and it's also in this lecture right here, which you'll watch and you'll be ready to go. But you won't have to do that for today. Today you'll just learn this from me. And then we do the lab. So every time where it says lab number 1, next week it'll be lab number 2. I put the wrong date down. I was confused. I don't know what happened. And then we have some example note forms. But let's take a look at this, what we're going to do today, and then we'll talk about how we're going to record what we did today. So let me ask you a question. If you were working for an engineering firm or an architectural firm, and you went out in September and did a survey, you did a whole bunch of data and you collected it. And then in March, your boss came back to you and said, we need to get the data more tightened up on this side. You know, there's something here, we need to get this defined a little bit better. How much do you think you're gonna remember, since you've done 6 projects and had Christmas and, right, you're not gonna remember anything. I mean, while you're doing it, it seems very clear what you're doing. When you have to come back to it, we don't want to have to go back and reinvent the wheel. We want to find that book and say, remind, oh yeah, that's where I was. So I need to tighten up between these 2 things. And the other thing is, as an engineer or a drafter, and this is probably true for any field, but we end up talking to people who don't necessarily have a technical background. And so your boss may not say to you, I need you to go out between this benchmark and that fly point and tighten up the data to, you know, I need to get 10 shots for one shot or something like that. He or she is just gonna maybe be, I don't know, a sociology major or a business major, and they're just gonna say, I need more data over here. So you have to interpret what that means, and that's why you need to keep good records. So they're not gonna, and that's kind of what we get paid for. You know, that's what engineers and doctors get paid for, is that technical expertise that you have, where you can interpret what they need from you, and then you can give them what they need without having them having to have an engineering or a drafting degree. Okay, so I've never in my life been paid if somebody gives me all the data and just tells me to calculate something from some equations. Nobody's ever paid me to do that. So you get paid for problem solving, and that's what we're talking about. So part of the problem solving is the data. Okay, so let's take a look at our first lab, which once again, I've got dates all over the place, but I think you guys can interpret what I'm talking about. Okay, so what we're gonna do today is lab number 1. We're gonna talk about an introduction to equipment. We're gonna talk about field notes, and we're gonna talk about pacing. So what we're going to do here is to find out the ultimate goal that we have today is to find out how long our pace is. Okay, so still have a few minutes, and then we're gonna quit recording. Basically, what your pace is 2 steps. It's like this, okay? And everybody has a characteristic pace. And it's pretty consistent once you get warmed up. If you're a little stiff, your pace is a little bit shorter. But almost everybody on the planet, of all the years I've done this, has a pace somewhere between 4 and 6 feet. So it's just very uncommon for somebody to be outside of that window. I did have a kid one time. He was a basketball player, and he was very tall, and his pace was 7.5 feet. It's quite unusual, and I've seen other people who had paces that are 3.5 feet or 3 feet, but most people, short, tall, regardless of gender, most people have a pace between 4 and 6 feet. So why do you think it might be important to know what your pace is?
You can measure.
Yeah, because you're always gonna have your feet, right? So if you look over at the tree and you go, how far is that? And you wanna know what kind of equipment do I need to measure to there, if you just pace it off, if you know your pace is whatever. You can estimate if is it closer to 300 feet, is it closer to 500 feet? So that's what we're gonna talk about today. And we're gonna use some surveying equipment to do that, but I'll break that out after we get unrecorded. So I'm gonna go ahead and talk a little bit about how that works. We're gonna use a field notebook, as we've already introduced. We're gonna use a steel tape, and we're gonna use something to mark the ends of the tape. So we're gonna pull off some data, and then we're going to record it in our field books, okay? Now, the next part, if I'm able to find this quick enough, that I would love to do. Here we go. This pre-lab work up. This is how you write down field notes. These are the big ideas, okay? So basically, you can find this, but there are things that you're trying to get at for your notes. And basically, you're trying to come up with a set of notes that is accurate, has integrity, is legible, that the arrangement and clarity contribute to you getting data out of this material. Data that you can quickly glance back at and start where you left off, okay? So the way that we arrange notes is we have the project name, the location, the date, start and finishing times. That's also important because like maybe something happens, maybe there's a weather event, you know, maybe somebody gets sick, but you just need to make those things. You want to put those clearly in the notes. You want the general weather conditions, the party, meaning who surveys with you and who does what, who's taking the notes, who's holding the stick, who's putting in the pins, all of that stuff. Instrument type and number. Here, it's not that big of a deal. I have 2 total stations and 1 or 2 of everything else. If you work for a big firm, you might have 11 total stations. If one of them is flawed and you use it, and you see that the errors are not yours, but they belong to the equipment, that's an important piece of information. So you always want to tell what you're using, and then you sign it in the lower right-hand corner. That's just to say, yep, I did it and I'm okay with it. All right. So, in general, what we want to do, if in doubt, write it out. It's more important to have more information than less information. If you leave something out, you're gonna regret it. If you put something down that you did not need, it'll be fine. Okay, write what you read. So in other words, don't do calculations. Don't say, oh, this end of the tape says this number and that end of the tape says that number, so the difference between them is this. And you write down the front and the beginning end, and you do the calculations when you come back here, which I call this our office, right? Come back to the office, you do the calculations. So when you read a piece of data, that's what you write in your field book, okay? It also tells you to use a pen, India ink, or a hard pencil. What that really means is you don't ever wish to erase from this, okay? So if you make a mistake, you need to leave evidence of what that mistake is and then correct it in your field. Okay, the best way to do that, if you write something down and it's just gobbledygook and you don't like it, draw a single line through it like that, and then write the correct thing above it, or underneath it, if there's more room. Okay, let's just say you just made a whole mess of this whole page, still don't tear it out. You do that, big extra. Okay, the other thing is, speaking of pages, both sides are considered a single page. If you notice, they're a little bit different. This is columns and this is a grid. Okay, so this is considered the left half of the page, this is considered the right half of the page, but this is considered one page. So if you made a mistake on one side, you would probably X out both sides. Just start over. Here. India ink, it suggests that. What a pain to do. I just like a hard pen. I just like hard pencils or just a pen. You know, but just have something that is not going to make it look like you are trying to hide anything or cover anything up. Okay. All right. So at this point, do you guys have any questions? All right. I just want to take a peek here, just make sure I'm not forgetting anything I wish to do. Let's see if this will load for me. Okay, so you can see this is taken not from this sort of a book, but from this sort of a book. You can see down the middle here, we have the grid and we have the columns. We have the word pacing, that's the name of the lab. And then we have some data. And then if we're to do some calculations, we would put it down below. Up here in the upper right, the student put their name, the date, what the weather looked like. And then the people in the party, the people that they surveyed with. So Chris surveyed with Eric, Condia, Dylan, and Christopher. And then when she was done, she signed down here. Okay, so it's not complicated, but it's really clear. You know, I mean, even though I apologize, I cut this off when I took a photo of it, but all of the data is there. And if there was something missing, for example, here it says 25 meters, and you can see that her pace, she made 16 and a half paces, 14, 17, 17, 13. What do you think if one of those pieces of data said that she took 64 paces? It'd be really clear that that was an error, right? So put a line through it, you're good to go. All right, so any questions? You already start surveying? All right. All right, so this is it for the lecture today. I'm going to go ahead and quit recording. And then I'll get out some equipment and we will do a little survey.